Hello students, welcome to RD Chemistry. We'll discuss briefly the Charles law. According to Charles law, volume of fixed amount of the gas is directly proportional to absolute temperature. What is the absolute temperature? The temperature expressed in terms of Kelvin scale, and this is at constant pressure. At constant pressure, or V is equal to one constant K into temperature T, or V by T is equal to K at constant pressure, or for different conditions initial and final, V1 divided by T1 is equal to V2 divided by T2 at constant pressure. Okay. Now we shall plot the graph for this. We'll take a volume is directly proportional temperature. Now let me take the Kelvin scale. Later let me take the degree centigrade. Now if I plot, okay, so I got volume here and the temperature I'll write T in terms of Kelvin scale. So this will be the 0 Kelvin and 0 volume. Since they are directly proportional to each other, it's going to be a straight line passing through the origin, right? That means when the temperature becomes 0 Kelvin, volume is equal to 0. Remember, this temperature is called as the absolute 0. It is called the absolute 0. What is absolute 0? Absolute 0 temperature is the temperature at which volume becomes equal to 0. That means the gas do not exist. Okay. Now if I go for temperature in terms of degree centigrade, So let me write small letter t in terms of degree centigrade. So I should have the 0 scale here, 0 degree centigrade, then positive values and then the negative values. Okay. Now what is the plot now? Plot will be such a way that we will be having the straight line again, but that will not go to the 0 degree centigrade. That will be somewhere here like this. And this temperature is equal to minus 273.15 degrees centigrade. If I convert this temperature into Kelvin scale, and this will be equal to 0 Kelvin actually. Okay, so this is the temperature at which gases do not exist, and this is the imaginary temperature. There is also called as the absolute 0 temperature. When I say absolute in terms of Kelvin scale, in terms of degree centigrade, minus 273.15 degrees centigrade. Okay, fine. Now let us have different types of the pressure. We'll plot the different pressures now. Different pressures. Now when I plot the volume versus the temperature, let me take temperature here in terms of degree centigrade, and I'll be pushing the scale this side. Let it be minus 273.15 degrees centigrade, and it's like a 200 minus 200. This is a minus 100, then say 0 plus 100 plus 200. Okay, so initially we'll be having the graph like this. So let the pressure be P1. Okay, now I'll change the pressure. For that I need to change the temperature. I need to keep the temperature same. Assume I'm keeping the temperature same. Assume I'm keeping 0 degree centigrade only. This is the pressure. Okay, P1 is the pressure, a corresponding volume. What I'll do now, I will change the pressure. 0 degree only, 0 degree only. Okay, now I'm going to change the pressure. Let the pressure be equal to P2. Now the pressure I'm going to increase, let it be P2, more pressure. If I increase the pressure, what will happen to the volume? Volume will decrease at the same 0 degree centigrade, correct? So let it be here. So actually the second graph will be somewhere here. This is the P2. That means if I go on increasing the pressure, that straight line will move toward the x-axis. Okay, so in this case, P3 greater than P2 greater than P1. Okay, right? Let us see this problem now. volume occupied by the gas at 1 atmosphere pressure, 0 degree centigrade, is VML. Its volume at 273 Kelvin will be. Okay. Temperatures they are changing. Volume also getting changed. Volume also getting changed. They're asking for the new volume, which means what is the fixed here? Atmosphere, 1 atmosphere fixed. Pressure is a constant. Okay. If there are different types of the gas laws, then see which one is the fixed there. Based on that, we can solve the problem. So now this is the Charles law. Okay. So therefore, according to Charles law, V1 divided by T1 is equal to V2 divided by T2. The temperature must be in terms of Kelvin scale. Initially, volume is a VML and its corresponding temperature is given 0 degree centigrade. 0 degree centigrade plus 273 Kelvin, I'll write approximately, not 0.15. So it is equal to 273 Kelvin. The new volume will have to calculate. What will be the new volume? And for that temperature already given, it is a 273 Kelvin itself, not degree centigrade. Remember, both the temperatures are same. When both the temperatures are same, volume will be same because volume is directly proportional to temperature. So V divided by 273 Kelvin. This was changed from degree centigrade to Kelvin scale is equal to, okay, is equal to V2. The new volume will have to calculate divided by temperature given in terms of Kelvin scale itself. So 273. Therefore, V2 is equal to V divided by 273 into 273. It will get cancelled. Therefore, it is equal to V itself. So volume would remain the same. Okay, fine. What is Avogadro's law? According to Avogadro's law, equal volume of gases will have the same number of molecules at given temperature and pressure. Okay, that means the volume is directly proportional to number of molecules. Okay, but number of molecules can be conveniently written as or converted into number of moles. So V is a directly proportional number of moles. When equal number of moles are there, it will contain equal number of molecules also. Right? Now remember, 1 mole of any gas, 1 mole of gas, okay, occupies 22.71 liters at STP or 22.4 liters at NTP. What is the STP and TP? STP means temperature being 0 degree centigrade and pressure being 1 bar pressure. NTP stands for normal temperature pressure. Temperature is same 0 degree centigrade and pressure being equal to 1 atmospheric pressure. Okay. The volume occupied by 1 mole of the gas is always known as the molar volume. Molar volume. Molar volume values can be different. It can be 22.71 or 22.4 depend on the condition. So volume occupied by 1 mole of the gas always called the molar volume. Molar, 1 molar. Okay, fine. Right? Please do subscribe, share and like the videos. Thank you for watching. Have a nice day.